Hi guys, let's talk about the hydraulic trainer here, all the components that you will be working on. So if we look at this trainer here, it has a lot of components. Let's start with the basic one here. So this is the hydraulic tank, which is filled with the hydraulic oil, and the type of oil we use is 32 CST. So this oil level is up to 3/4, and you look at it as height class, and this is the fill cap here. So when the oil level goes down, you fill the oil from here. And this is a normally shut-off valve. We call it a cavitation valve that you'll never see in industry. And this is an aeration valve that allows the air to go into the pump that you will also never see in industry. These are done purposely because it's a trainer so that you can see the effect of cavitation and aeration. So this is the pump. It's a gear pump. And the electrical motor is right here, and between the pump and the motor shaft connected together with a little coupling, and this is a little guard on the coupling. And now this is the pump start and stop button here, and this particular one is solenoid valve A and B. So this is a solenoid directional control valve, and this is a pilot operated relief valve which will set the system pressure to 500 psi. Like in industry we use 2500 psi system pressure, but here we only use maximum 500 psi because we're not making any production. We're just learning how the hydraulic system works. Now, if we look here, this line, this is the suction line, oil going to the pump, and this is the discharge line. So this line goes here to this manifold, which is the pressure lines. So we have 1, 2, 3, 4 pressure lines available, and 1, 2, 3, 4 return lines available, and these are the drains. The difference between drain and return, they all go to tank, but return line has some back pressure. Drain is no back pressure, it's simply going oil back to the tank. So if this valve, this is the deceleration valve, so this is the drain line here. You see this drain line? So we connect this to one of the drains. And like on this valve, this is drain, that connects to drain. Like on this valve, the bottom one is drain, and this connects to drain. Alright, so this is a pressure relief valve that we will set the pressure. We will make sure that this handle is closed, the valve is closed, so that it can build up the pressure. Now let's look at the components here. So this component here is a hydraulic motor, like the symbol shows. You see the triangle pointing inward. So that means this is the motor, oil is going inside, so it's going to spin the shaft of the motor. And you see here the drain line, it's a permanently connected drain line connected to the drain right there. This valve. So this is your 4-port A, B, P and T, and 3 position, 1 position, 2 position, 3 position. Directional control valve, solenoid operated, spring centered. This valve is a lever operated valve. You can see, move the lever left and right. This one again is 4-port, 3 position. You can see port A, B, P and T. And this one is a lever operated one. And this is an open center one, and this is closed center one. And this component here is a flow meter. So what this does, it measures how much flow is passing through the meter. And it's going to be indicated with the pointer. You see the red pointer here? So this goes from 0 to 5 gallons per minute. And our pump is 2.8 GPM, so that means 2.8 gallons per minute. So we make sure we connect in to in, out to it, because the oil only flows this way for the pointer to indicate how much flow is passing through. And this is the symbol for that. These are your pressure gauges. So they can read from 0 to 1000 psi range. We are only using 500 psi, these 2 gauges here. And then we look at the cylinders here. So we got the horizontal cylinder and a vertical cylinder. So when you're building a lab, you make sure you use the right cylinder as shown in the schematic. Now, these valves, you might be familiar from pneumatics. So this is a flow control valve. This is a flow control valve with built-in check valve. You can see the position of the check valve. And this is another separate check valve. So if the oil goes here, is a free flow. The coming that way is no flow. And this one is the same as this one. We have 2 of these. So this is the flow control valve with built-in check valve, and this one is just a check valve. And this is a very special valve. You see, it's a flow control valve, variable flow control, right? With an arrow pointing upward. So that means, and this is in and out specifically written here. So we have to put in and out to out. This one could be anyone in and out, doesn't matter. So this pressure compensated flow control valve, you know, in hydraulics, your speed is pressure dependent. So more pressure, more speed. But when we use this valve, and what it does is when there are fluctuations of pressure, the flow remains the same. So the valve adjusts automatically inside to give you the same flow. Same flow means a particular cylinder will always travel with the same speed regardless of the pressure fluctuations in the hydraulic system. And now let's look at these two valves here. So this one is a normally closed valve, you see, in and out. So the pilot line will open when the pressure build up in the pilot line enough against the spring adjustment here on the knob. So we can use this as a sequence valve or as a counterbalance valve. And this one is a pressure reducing valve. So what it does, it reduces the pressure. So if your system pressure is set to 500 psi with the relief valve, we can set this pressure to 300 psi, for example. So this mole, this cylinder will close the mole with 300 psi out of maximum 500 psi system pressure. So the other components on the machine might be working with 500 psi, but this particular cylinder, we want the pressure behind the piston to be 300 psi, so the clamping force is reduced for a mold or press or die. Alright, so these are all the components I explained you on this particular workstation. Now the last thing here is this valve. So you see here, this is the symbol of the valve. This is called deceleration valve. All it does, it reduces the speed of the cylinder when the valve is pressed. Is pressed here, when the spool is pressed. Normally we should have this valve during extension, but because of the space limitation, they installed it during retraction. Alright guys, so these are all the components here. So now let's talk about a little bit about cavitation and aeration. So now let's talk about these two valves. This is a cavitational valve. This is a normal shut-off valve. It's going to simulate as a cavitation valve. And this valve is just a flow control valve with a little filter inside here, this one. So we call it aeration valve. Now what is cavitation valve is, you know, when the pump starves of oil and cavitation is created. Now, what is cavitation means when there is not enough oil going to the pump and the component inside the pump run metal to metal and the pump burns in few seconds. Now, how does that happen? Is mainly when the suction strainer inside the tank, there is a little suction filter here that picks up all the impurities before the oil goes to the pump so that the pump can have a longer life. Now when the suction strainer is dirty, you don't have enough oil going to the pump and the pump components run metal to metal and the pump burns. So how we simulate that is we close this valve. So remember, when the handle is parallel to the pipe, the valve is open. When the handle is 90 degrees to the pipe, the valve is closed. So if I close this valve and I start the pump, in 5 seconds the pump will blow and it's $500 pump. So what we're going to do is I'm going to slowly open it, slowly close it to simulate it that not enough oil is going to the pump and you hear the sound, a rattling sound metal to metal, and that is the sound when you hear on a hydraulic equipment, means the suction strainer is dirty most likely. And the aeration valve is when I open this flow control valve, all the atmospheric air goes inside the pump and it creates a special kind of sound, and that is, we call it aeration. So we don't want any air to go inside the pump, we don't want any starvation in the pump, so we're going to use these two valves to simulate that. So when I start the machine, I'll show you how it sounds. Okay, so right now we're ready to start the machine. So guys, in order for me to show the cavitation and aeration, we need to start the machine. So I can just start the machine and set up the pressure to be 500 psi. So this is how I started because the pump was off for a long time. So I just want to prime the pump even though we don't need it. So I can start and stop. So right now I primed the pump, so now I'm ready to start it. So I'm going to close this pressure relief valve, which is part of the pressure relief valve. I make sure the guy before me shut it down properly. Yeah, now I close it. So I turn this knob and I set the pressure to be 500 psi. Right? So now my system pressure is 500 psi. Now the 100% of the oil is going to the pump. So now I'm going to create a situation of cavitation. So what I'm going to do is I'm going to slowly close this valve, and you hear the rattling sound in the pump. It's going metal to metal, which could cause a serious damage to the pump. But what I'm going to do is I'm going to do it only for a few seconds so you can hear the sound. Okay? See, I'm closing the valve. So not enough oil going to the pump, and the pump will cavitate. You see that? That's very dangerous. That kind of sound is very dangerous. It's going to damage the pump. So that's why I had it only for 1 or 2 seconds. Now this is the sound that you heard is from cavitation. Now I'm going to create a situation for aeration. So this is the aeration valve. So it's just a flow control valve. It allows the atmospheric air to go to the pump. You hear that? It's a little different kind of rattling sound, but that is called aeration. Alright, so now I'm going to shut the machine off. So I release all the pressure, open this valve, and shut the pump.